This is chapter 12.5, approximately the area of a region. So we're going to look at specifically number 27. We need to we're going to complete the table to show the approximate area of the region using the indicated numbers n of rectangles of equal width. So we're going to approximate given the number of rectangles of 4, 8, 20, and 50. So we have f of x equals x squared plus 1, and we have the parabola here. And so we note that our a value is going to be at -2, so x equals -2 and x equals 1. So this is our a and our b. And then let me write the formula that we're using, the sum of 1 to n of f of a plus b minus a over n, and that's multiplied by I, times b minus a over n. So just as a reminder that this is the this is the height here, and then this is our width. So we know a, we know b, and then we don't know, well, we do know what n is, so we'll plug that in a little bit later. So let's find our width first of all. So the width is going to be b minus a, so 1 minus a minus 2 over n, or 3 over n. So that's first. Now let's look at our height. That's going to be f of a, which is -2 plus this 3 over n I. And then we're going to plug that into the function. So this is going to be x squared, so that's -2 plus 3 over n I squared, and then don't forget the plus 1. So I'm going to simplify this. This is going to be 4 minus 3 times 2 is 6, and then we double that, so that's going to be 12i over n, and then plus 9i squared over n squared, and don't forget the plus 1. So we'll simplify this a little bit more and then rewrite it. So I'm going to put 9i squared over n squared minus 12i over n, and 4 plus 1 is 5. And so this is our height. So now to find the area, let's plug it in. So the area equals the sum from 1 to n of the height, which is going to be 9i squared over n squared minus 12i over n plus 5 times, that's the height, times the width, which is 3 over n. So what I'm going to do in this case is I'm going to go ahead and distribute now all the way through. So this will become the sum of 1 to n of 27i squared over n cubed minus 12 times 3 is 36i over n squared plus 15 over n. And then let's split it all apart. So we're just going to keep the I squared here, I there, and then we'll have a 1 here. Okay, so let's factor out the 27n cubed, 27 over n cubed. The sum of I equals 1 to n of I squared minus 36 over n squared, the sum of 1 to n of I, and then plus 15 over n, and then times 1. And then let's substitute. So this is 27 over n cubed times n plus 1 times 2n plus 1 all over 6 minus 36 over n squared times n plus 1 all over 2 plus 15 over n times n. So then now let's reduce where I can. So I'm going to change this n. This will become an n squared instead. So 3 goes into 6 2 times. 3 goes into 27 9 times. So let me write this first term first. So 9 times n plus 1 times 2n plus 1 all over 2n squared. And then minus, let's simplify here as well. Take out this n. This is canceled. 2 goes into 2 once, 2 goes into 36 18 times. So minus 18 times n plus 1 all over n. And then this cancels out, so this will just be 15. So this is what I did first because I know we need to. So going back to the beginning, it said that we want to approximate the areas using n is 4, 8, 20, and 50. So how I handled this problem is I went ahead and plugged it all in and got it to this point here. And now I'm going to plug in 4 here to solve, and then 8, 20, and 50 into my calculator to get the answers. So just to kind of write it out real quick for you, if I were to solve this, so if we have n is 4, then 9 times 4 plus 1 times 2 times 4 plus 1 all over 2 times 4 to the square minus 18 times 4 plus 1 over 4 plus 15. So this is 9 times 5 times 9 over 16 times 2 is 32 minus 18 times 5 over 4 plus 15. And so, use your calculator at that point and you would get 5.15625. And then you do the same thing for n equals 8, n equals 20, and n equals 50. I find doing it this way first, instead of doing the problem, like plugging in n right away, so if you were to instead, I'm going to plug in 4 here and then solve it all the way through, and then do the same thing for 8 and 20 and 50, that would take a way longer time. So this might be a nice little shortcut to help you through this problem. This problem as well as number 25. And so I hope this helps you out.